The great space race is made possible by a grant from the Boeing company, in tribute to those who have dedicated themselves to the exploration of man's next frontier. There are not too many subjects upon which the Soviet Union and the United States agree. There is, however, one point upon which they are in total agreement, and to many people it is a startling one, and that is that the episode of human life being confined to Earth is coming to an end. Space will be the next civilization. Here in the Soviet Union and in the United States, plans are on the drawing boards for space colonies.
Certainly, Moon and Mars are the first candidates to settle.
We certainly will have a Mars colony. The only real question is, how soon do we do it?
Around the turn of the century, either the United States or the Soviet Union will perhaps have the systems ready to do a manned reconnaissance of Mars.
We will see modest-sized space colonies of 10,000 to 50,000 people located near resource bases and dispersed fairly widely throughout the solar system. About that time, of course, people are going to be starting to think about the issue of migrations to other nearby star systems.
US and Soviet plans call for a base on the Moon in 2 decades, a colony on Mars by the year 2035. Why? What would they be like? How would they work? According to experts, we have reached the point in history where past fantasies are fast approaching reality, a reality perhaps even more extraordinary than we imagined.
Drift into the right a little. Contact light. Okay, engine stop. We copy you down, Eagle. Tranquility Base here. The Eagle has landed. I'm going to step off the lamb now. That's one small step for man, one giant leap for mankind.
During the Apollo program, a few Americans were able to take a brief trip to the Moon. In the 21st century, many Americans will be able to live there permanently, and others will later go on to settle Mars. It may very well be that the first Martian settlers have already been born.
We have this enormous universe all around it, all around us, and almost everywhere we look, we see wonderful things, marvelous variety of things going on. No sign of anything alive except on this one planet. That seems to me a very unnatural situation, and it's something that's not going to last. One way or another, life is going to get loose, and the universe is there, and life is going to come into its heritage somehow or other, and perhaps it's our job to bring this about.
We have passed most of the barriers that we need to pass, and psychological and technological barriers we need to pass in order to have permanent settlements on the Moon or permanent settlements on Mars. I really don't know of any technological barriers that exist, certainly none that seemed to exist when we made the decision we were going to the Moon.
Proposing to live in space, establishing permanent settlements, may seem unimaginable given earlier fears and prophecies about even sending man up for a brief voyage.
Way back at the beginning, when we first started the thing, of course, the question was, could he even last for a few minutes? We had things like people were saying that you'd never be able to urinate in the weightless state. Other people said you're going to urinate all the time. You're not going to be able to stop urinating. So they were all conflicting things. Some people said you're going to sleep all the time. You're never going to be able to keep them awake. Other people said you're never going to be able to get to sleep. Before that first 4-day flight, we were getting phone calls clear up all that night before the launch. I documented a whole stack of phone calls from around the country, physiologists and physicians who were telling me we were killing these two men.
We, in fact, have discovered a great deal from each flight about the problems and the possibilities awaiting space settlers, physically and psychologically. The Soviet Union has done the most work so far in exploring long-duration flights and what actually happens to man over the long haul in space. The Soviets have concentrated on space station technology. Recently, they launched a new one, and the problems of keeping man in space. Prior tests on their Salyut station cosmonauts revealed definite problems of weightlessness, cardiovascular changes, some bone demineralization, loss of muscle mass. But ultimately, they have come away, as have the Americans from their missions, with the feeling that these problems can be managed.
Each new flight gave a chance to our physicians, to space medicine, to fight this type of obstacles. And I think now we can tell that 1, 2, maybe 3 years is not the limit for men in space.
I think every system in the body will have turned over within a 6-month period, and therefore I think you can predict it. You could go to a Mars mission if you could see no real bad effects in 6 months. And I personally believe we could do a Mars mission, 2-year mission, without any difficulty now.
The combined findings of the U.S. Skylab and Soviet Salyut missions have also compiled a portrait of the psychological problems permanent space settlers would face.
People can put up with a whole lot for about 28 days. And then within 28, 30 days, the little things begin to get you, they become more important and the stresses begin to increase. So they figure that it's camping out for up to 28 days. Beyond 28 days, the whole thing is it's a qualitatively different experience.
What about psychological problems?
To go for these long-duration flights. Well, I think that the thing that we've really seen, even in our flights, and certainly the Russians have added to this greatly by their 6-month missions, is that you have to provide some contact with life as we all know it and live it normally. And so it's very much like what's happened with our Arctic explorers and so forth, too. Anytime you have total isolation, you need some contact with what is real. And you can do some things about news. You need some contact with your loved ones and to be able to talk to those loved ones. And they have provided that. The Russians have provided that. We provided that even, we started that even in the Gemini series. We did that.
I think permanent online touch with the Earth using video channels, audio, help very much for cosmonauts to overcome this difficulty. And I do not think that psychological barrier now is a difficult one.
Living in space is something that man has dreamed about for centuries. Most concur that the first step toward this future is a space station, which can serve as a base from which to build settlements on the Moon and Mars. The Soviets' current concentration on this is nothing new. It was here in the Soviet Union that the first plans for a space station were drafted. Surprisingly, not in the last decade, but at the turn of the century.
The Russian space prophet Tsiolkovsky drew some beautiful plans for space stations, which are as good today as they were then, and very much a model of the future.
Tsiolkovsky was a Russian schoolteacher at the turn of the century who was considered a madman in his own time. Today, his portrait hangs on Dr. SAGDEEV's wall. He envisioned a space station not too absurdly removed from today's designs. He was joined years later by another visionary.
In Collier's magazines in the 1950s, Werner von Braun and some of his friends put together some beautiful illustrated colored drawings of space stations.
Werner von Braun, the World War II German rocket expert who went on to formulate the beginnings of the U.S. space program, had elaborate designs mapped out. He foresaw fabulous possibilities for men living and working in space. His thoughts in many ways were the prototype for the space station of today, because Tsiolkovsky's madness of 1910 is becoming the reality of the 1980s. The specific design for a station to allow the U.S. its first real era of permanent occupancy of space is still being debated, but it is clear that it will look something like these models.
The main core of the space station is a big, tall, cruciform structure. It's about 400 feet long. It's about 250 or so feet wide. The cruciform structure flies around the Earth. If my fist is the Earth, the long axis of the cruciform is in a mode we call gravity gradient, and it's always pointed at the surface of the Earth, the same end. It flies around the Earth like a pencil, with the pointy end of the pencil always pointed at the Earth. So we put instruments that we want to look outward to the sun and the stars and so on, the celestial sphere on the top of the tower, and we put instruments that we want to look at the Earth with down on the bottom of the tower.
Plans now are to use the shuttle to build the space station. In one of the century's more incredible construction undertakings, it will literally carry it up piece by piece.
So our concept is, since we are limited by the shuttle, and the shuttle is the primary launch vehicle, we have to divide the space station up into logical parts and take it up and construct it or build it when we get on orbit. The manned core of the station is constructed of a grid structure that's basically made out of what we call a box truss, kind of like a scaffolding. Each part that we take up has to be self-sufficient without humans, because we have to take up an unmanned part and leave it. Shuttle has to come back and go back up later with another part and attach onto that. And while the shuttle's not there and while there aren't any people there, of course, the thing has to stay in orbit and have electricity, and we have to be able to send radio commands to it and so on. I would guess it would probably take us somewhere on the order of a year, with launches spaced a month or two apart, to be able to construct the entire station.
U.S. planners envision the space station as a place to conduct more research on the effects on man of living in space permanently. It will also carry out work now being done on the shuttle, materials processing, scientific experiments, all in a greatly expanded way.
The space station gives you the opportunity for man-assisted research. Laboratories where you have automation, you have robotics assisting human beings, participating with ground-based investigators, really doing science like we can in terrestrial laboratories. First of all, we have the interior core laboratories, where we anticipate there will be 8 to 10 scientific crew members working in laboratories, having furnaces, having centrifuges, having animal holding areas to do biological research. Then on the outside of space station, we have the attached payload section. With attached payloads, you can put instruments in the vacuum of space that both look to the sun, look to the stars, and look back at the Earth. That's the real payoff we see in the next few years, the first-class science in space.
The ultimate payoff, say planners, is that it will become the stepping stone to the real future in space.
First and foremost, the space station will also be the way station. It'll be the Cape Kennedy in orbit, from which all of the expeditions that we send out to return to the moon, to explore the asteroids, to open the first bases on Mars, All of those will be staged through the space station, and when they return, they will return to the space station. They'll use aerobraking in the Earth's atmosphere and then dock and land at the space station, and those spacecraft will stay in orbit ready for the next trip out while the men return to Earth and the women in the shuttle.
Traveling regularly between the Earth, the Moon, and Mars is going to require new systems of transportation, new systems that dramatically increase speed and decrease costs. According to General Chuck Yeager, the first man to break the sound barrier, we are on the threshold of an amazing new era of space transportation, one that may seem fantastic unless you look at where history has taken us already.
Most people have trouble crossing the so-called barrier or associating space travel with routine commercial travel as we know it today. You know, 50 years ago, not one person predicted that jet aircraft would be used to carry passengers. In fact, jet aircraft weren't even anticipated. So today, we at the National Commission on Space see space transportation in the future, 20, 30, 40, 50 years from now, it'll be handled as routinely as commercial transportation, as commercial cargo is today. Now, the X-31 aerospace plane, what does that aircraft do? It gives us the capability of taxiing out on a runway, take off with turbojet power, accelerate out to Mach 3 or Mach 4, then go to ramjet, go out to some 5 or 6 times the speed of sound, then go into supersonic ramjet technology and accelerate out to some 12 to 15 times the speed of sound, and in the meantime, gathering liquid oxygen to give it that dual chemical capability to mix with the liquid hydrogen that you're carrying as a fuel in the vehicle in order to put it into orbit.
Kind of speed translates into down here on Earth means quite simply that you could fly from New York to Tokyo in less than 2 hours. Along with the aerospace plane, planners are designing orbiting transfer vehicles. These are high-speed taxis that can be serviced at spaceport hangars, loaded up and sent out to aerobrake down onto the Moon and Mars with cargoes and crews. The combination of the aerospace plane and these orbiters could open up all sorts of possibilities. The experts foresee a fascinating new era beginning. To date, the astronauts have been the only space tourists, but that might not be the case much longer. This little girl might grow up taking vacations to the Moon and excursions through the solar system. The first space tourist, experts say, may pay up to $1 million a seat for a brief ride into space, but the price will drop rapidly as the systems begin to function regularly.
Once we get those systems in being and make it productive, because that's the object, is the commercialization of space, then yes, we will see quite people like yourself and myself, if we want to pay the price, go on a trip.
The real trip the planners have in mind is not tourism, but the Moon, our constant companion 240,000 miles away, and not for a visit, but to stay. In less than 2 decades, they say, you may be able to journey to a moon base, the next step after the space station. It is, they say, technologically totally feasible right now.
demonstrated, mankind has already demonstrated that it's possible to get to the moon and to spend some time there. So I think that in the absence of any great tragedies, that we must expect that people will go to the moon and attempt to set up a base there, and with the purpose of ultimately setting up a long-term base and then a self-sustaining one which can live in some fashion or provide its own resources without Earth support.
You have a very fundamental fact at work. One is that it's 1/6 gravity on the moon, it's 1 gravity here on Earth. And once you have a plant established on the moon, a lunar base, then it's going to be much cheaper to bring the raw materials that you need for an Earth orbital civilization of manufacturing facilities to Earth orbit from the moon than it would be to bring them from the Earth to low Earth orbit, to space stations. So you start with a very good economic justification for a lunar base, as well as the fun it's going to be.
The political competition that spurred on the U.S. space program when the Soviets successfully sent up Sputnik is alive and well. In fact, according to experts at Johnson Space Center, it's one of the key motivating factors pushing the U.S. toward its lunar base.
Well, all of the large projects that have been done in space, the Space Shuttle, Project Apollo, have been essentially political decisions. And I think it will be no different when we decide to go to the moon again. There'll be some political decision. If there was a base on the moon that was Soviet, I'm sure that the American people would feel very strongly about that kind of activity. Do the Russians have the moon? Even though it might not be able to be shown clearly that there's a strategic advantage, there's still a psychological advantage, particularly among peoples in the world who are trying to evaluate what kinds of systems to choose in the way they grow and develop their own nations.
The trip to the moon will begin with the aerospace plane. You'll ride from Earth up to the spaceport. At the spaceport, you'll get into an orbital transfer vehicle and take it, like a taxi, to the moon.
Our guess is, and it's probably true, the first places to live will be space station modules. We'll have to bury them under about 10 feet of lunar soil simply because there's a radiation hazard, a continuous hazard from solar wind and solar particles, and so people have to be shielded and live underground in a sense. But those will be the first habitats. They'll be the first labs, the first living quarters, the first machine shops, and so on.
People would kind of have to be like cavemen most of the time, but with quite an adequate amount of sunlight to grow food and in closed atmospheric environments, because there's one thing that we don't have there is an atmosphere.
Living on the lunar base will be to live in a world of high-tech and robotics beyond what most of us can imagine, and certainly beyond what most of us live in now. Factories on the moon, say experts, will begin to provide the necessities to build housing, vehicles, and other equipment needed to live and expand colonization.
On Earth, we have very highly automated factories coming into fashion because of high labor costs. On the moon, the very automated factories will be useful because they reduce the exposure of the people to the environment. So there will be an important role for automation, for some kind of artificial intelligence, if you will, some kind of autonomous function for the machines in the lunar environment that will be an integral part of whatever society and activities develop there.
Mining of local resources will be the first major economic activity on the moon. These resources, they say, are significant, not only for making life viable on the moon, but for potential long-term economic gain.
What are those resources? Well, probably the one you want most is oxygen. Not only oxygen for habitation purposes. But oxygen for transportation fuel, or oxidizer rather than fuel, oxygen that is just a tremendously valuable element. And the moon is made up mostly of oxygen. At least 50% of the planet is oxygen. And there are ways in which we know how to extract that oxygen from those rocks. In addition, you have elements in significant abundance, such as titanium, iron, aluminum, silicon. All four of those elements are really metals of our present and our future. Tremendously important metals that we're using increasingly here on Earth already for very special purposes, and I think will be, as iron and steel have been to our generation and aluminum have been to our generation, you'll find that titanium and silicon are the metals of the future space civilization.
It's very logical, and it's exactly in keeping with all of human history up to the present time. What's happened is that we have moved into new areas for economic reasons to exploit the resources that were there. And of course, in space, the real long-term resources are abundant, free, clean energy from the sun, and the material resources in space, the moon initially, and in the long term, the asteroids, which contain enormous reserves of all of the elements that are needed in manufacturing. So what I would see happening is, for probably the first decades, the mines to be basically on the surface of the moon and the manufacturing to be carried out in space, for all the right reasons. It's nearby. We can carry out a lot of easy operations there with radio and television control from the surface of the Earth, a lot of use of robotics, but it's a place we can get to quickly and easily if we have to fix things when they break.
This original moon base will also be an outpost for scientific research that some feel could bring us profound insights.
We'll go there to develop resources. We'll go there to emplace new scientific observatories of tremendous capability on the back of the moon, where radio waves from the Earth are not penetrating. We can put the giant radio telescopes, the Arecibo telescopes of the future will be in lunar craters on the far side of the moon. It will be a place where we go for many different research purposes.
As an astronomer, I've been involved in the search for materials way beyond the solar system. Using our telescopes, we can look out at other stars and see what they're made of. And we find that they're made of very much the same kinds of chemical elements that we find within our own solar system, in the sun and in the planets.
Once we have a base on the moon with people going back and forth freely, there's probably no limit to the scientific exploitation of that capability. We haven't really begun to investigate all the possibilities that there might be from using a lunar base for science. We're hoping to develop a view of the Earth that will enable us to predict the climate over long periods of time, so that humanity won't get into trouble if something goes wrong. We are trying to find out, why is it that our own sun apparently is very active and from time to time emits radiations damaging to life? Why should there be a massive black hole at the center of our galaxy? We don't know. It's one of the mysteries. We're making plans as part of our program to see if we can find planets beyond our own solar system. And that would, of course, be an exciting discovery, because it would raise the whole question as to whether there might be life out there also.
The moon base will initially be a world in which scientists and technocrats and the people comfortable with technology will do well, in much the same way that that's been true for our smaller endeavors, for instance on the space shuttle.
On the moon, the technology in the society will be much more pervasive in everyday lives. So people who are comfortable with that technology, with the understanding of how to interact with it and how to use it as an intermediary to the environment, will be the kinds of people who will be let's say, most successful in adapting to that particular kind of lifestyle. And so once you make that sort of statement, then maybe you're making statements about the kind of people who will live on the moon, will choose to live on the moon. And that gets us into questions of about what kind of society evolves out of something which starts out as a technocracy in some ways, where engineers and scientists and technicians are the people who have the survival skills.
Many are fascinated by this question. Just what sort of a society will develop in this strange, distant, isolated, robotized colony? And furthermore, what kind of government?
One of the intriguing questions that comes up about lunar bases is how are they going to be managed? How are they going to be governed? Is it going to be the United States with a base here, and the Soviet Union with a base there, and Europe with a base somewhere else, and Japan and Asia with another base? And that's more or less been the history of settlement on the planet Earth, of new geographic frontiers, and is currently the situation in Antarctica.
Antarctica, many say, could give one the idea of what life would be like on such a base, as well as some ideas for running such a place.
Antarctica is a place which is not that different from outer space. And there what's happened is quite interesting. It's been demilitarized. There is no defense in Antarctica. It is not military. The powers agreed to that. It makes very little sense to do it there. And so they didn't. And even our U.S. naval aircraft, who do such a wonderful job supplying the bases there, are definitely without arms there, and everyone knows that. The same thing is true of the Russians. And these people set up bases, and they visit each other by agreement and so on. And it's all pretty open and above board, and on the whole, a very good spirit has arisen in that strange continent. In an area as big as, more or less as big as the United States, at least 2/3 of it, there might be only a few hundred people. So it's a pretty empty place. Well, but you know the moon will be like that, too. The moon is as big as North and South America put together. And the lunar base, I suppose, will have 50 people on it. So I could imagine 2 or 3 lunar bases, but I would prefer if instead of, step 1, we have an island, they have an island. Step 2, you and I agree, and we have bases in Antarctica that visit each other and sort of cooperative, but they're independent still. Step 3, we go out to the moon, a new world, and we have a base which is joint. It doesn't cost anybody so much money, isn't even a little bit competitive. It's a mutual, cooperative thing. Both the great powers and the others too competing against nature, which has produced a vacuum of the moon, which is a pretty tough place to live. That's what I'd like to see, and I think that may be a very desirable outcome of the whole thing. Shifting over from a strictly military view of getting there first and occupying the high ground into a game of trying to live together as a joint single species confronting the difficulties of spreading out into the world beyond the Earth.
Some think, however, that moon settlers may very well want to establish their own independent identity, with their own independent entity, with their own particular form of law.
Maybe they'll insist on becoming the 51st state, become a self-governing body, establishing their own legislature, having their own governor, or what have you. If you look at our own frontier here on Earth, as they pushed west, you have the law of the Pecos. Somebody stole a cow and you hung them. Today it's very doubtful that you'd hang somebody for stealing a cow. But that was a law that they developed to meet their particular needs. And I think that's the way I would see the law developing if you were to have a lunar colony, a large lunar colony where people were going to live and work over long periods of time.
Beyond the moon, the planet Mars, 230 million miles away, is next on the horizon. According to leading experts, by the year 2035, you could be walking on a colony on Mars.
I would guess that sometime around the turn of the century, either the United States or the Soviet Union will perhaps have the systems ready to send the first men and women out to do a manned reconnaissance of Mars.
we are planning to have our own mission to Martian orbit. And during this mission, the spacecraft is planned to come very close to Phobos. And the idea is to send from the spacecraft a small platform which could land on Phobos, which could live there for a few months, maybe for a couple of years, and send signals to the Earth. In my view, it could play a role of mini Viking.
The U.S., having sent Viking to land on Mars, agrees with the Soviets. Mars is next. In fact, U.S. planners are already thinking about how to build the colony there.
You could dig a trench and put up a structure and then cover it with the soil material to shield you from solar flares and other bad things like that. To insulate it, you could have greenhouses. We think it would be very straightforward to put a successful colony up. It would be, Mars would be a nice place to live. If you put solar cells up, you could heat things. If you put a colony near the North Polar Cap, there's lots of water, which the solar cells could melt for you. You could even have an equatorial site and drill a well to get the permafrost, that is the frozen water that's underground. So it's much easier to live on than the moon. It's subject to planetary engineering because it has the one absolutely necessary thing that you have to have a colony, and that's water.
When will humans go to Mars then? Well, again, we're not predicting when it would be, but we believe that a perfectly good goal for America would be to lead mankind out to permanent occupation of Mars starting in about the year 2015. This would be 10 years after our first expedition to the moon. We would have learned enough in that decade about how you operate in other planets to tell us what the kinds of things we should do when we get to Mars are to sustain human life so far away from Earth. The journey out to Mars is going to be a fascinating journey indeed. Mars is going to take us about 6 months' journey at the very best, and it might even take as long as a year to get there. You'd begin at the same spaceport Earth that you used to go to the moon, but from there you'd journey on out to the L1 libration point, and at that point you would get into a very high-speed taxi kind of vehicle, and with a great spurt of energy, you would rendezvous with an enormous spaceship that is cycling continuously back and forth between the orbit of Earth and the orbit of Mars. For the next 6 months, you would be living aboard an artificial gravity, closed ecology, life support system, vessel that would be very much like an oceanographic vessel on Earth.
This vessel would be totally geared for a long-duration trip. It would be equipped with recreational facilities, as well as the smaller living modules, to make the long journey more endurable.
When you reach Mars, you will get back into your high-speed taxi and move on into the orbiting spaceport around Mars, or more likely docked to the Martian moon Phobos, which we believe may be a treasure trove of resources, including spacecraft fuel for the lander that will take us from Martian orbit down to the surface of Mars. You want to create a base on Mars, then you want to have people visit it. Some people will fly in, do a days or two work, and then fly back in the next trip out. Others will sign up for a one-year tour of duty down there, and they'll winter over, as it were. The first expeditions to go to Mars will probably rendezvous with material we've sent on ahead, so that when they get down to the surface of Mars, there will already be shelters and food and scientific instruments that we have landed robotically. We got a very good idea what conditions are like on Mars, and they are cold. At noontime, it very seldom gets above freezing, so it's going to be very chilly. But the atmosphere is so thin that it doesn't take the heat away from you very much. So a little insulation, and you'll be perfectly all right, like a wetsuit.
The Mars base will eventually evolve into a self-sustaining colony, built with enclosed living modules known as biospheres.
Biosphere really means the kind of an atmosphere in which the air we breathe, the water, and all of our waste products are recycled and the same way they are on the surface of Earth, used again to support continuing human activities.
Biology is just advancing by leaps and bounds, and we'll very soon be able to adapt plants, for example, to grow on all kinds of interesting places in space, on different planets, on different asteroids. I can see the time coming pretty soon when you can actually go and plant your potatoes and raise crops and build greenhouses and so forth.
Outside of Tucson, Arizona, the advanced study of artificial biospheres has begun. Housed in a series of greenhouses, the Biosphere Engineering Project is developing the systems necessary for humans to survive in self-sufficient, enclosed environments.
Joe, here in the experimental area of the Biosphere Engineering Project in Arizona, we can begin to see what it would be like if we were on the moon or Mars 50 years from now, in which we don't want to bring tomatoes from Earth. We want to bring seeds and then have the tomatoes grow and produce more tomatoes in a real growth cycle, much as the Americas were settled. We used the materials we found here. We didn't bring them from Europe. And the pioneering here is in the technology that brings the nutrients to the roots of these plants. This is different from the way we do it on Earth, but in the moon or Mars, we need to have this closed ecology cycle. So all of the air that we breathe, the water cycle, the food cycle, is all moved in an engineering fashion to keep life going on very remote from the Earth's natural biosphere. If we can indeed sustain these kinds of colonies in space, we're going to have all sorts of messages for how we can grow food on Earth in brand new ways in the future.
An important link in the recycling of nutrients involves aquaculture.
We're able to recycle some of the agricultural materials back into here so that they go to help nourish the fish. The fish, in turn, will eventually wind up not only human food, but also part of the fertilizer chain. One of the main differences between what we see here with the research workers tending the plants is that in the space colonies of the future, much of this will be done robotically. First, we have to learn to do it with humans, and then we can teach the silicon chips how to manage the activity. The amount of nutrient being recycled, the way the atmosphere is interacting, all of this will be done very scientifically with silicon chips, freeing up the people to do the things that humans do best. Just the broad overview of the entire enterprise, the outward look will be humanity. The details of the production, that we've got to learn to do with robotics. In many ways, here we're seeing the wave of the future.
Ultimately, synthetic biospheres will evolve into sophisticated habitats that can recreate a variety of environments from Earth.
It would have components of agriculture. It would have components of the various types of living environments we have on Earth, the savannas, the seashores. Each part of the component here adds one more type of living environment to produce the multiplicity of things that go to support humankind here on Earth.
Once the biospheres become more sophisticated and comfortable, say the experts, life in space might not only be tolerable, but begin to flourish in new ways.
all of a sudden we have totally new capacities. We can do all kinds of things in 0G and 1/6G if you're on the moon. So you may have three-dimensional tennis. You may swim on the side of a ball, you know, where the water will come all the way up around and you swim on the edges and look down to the beach. And you may be able to, you know, the body will be able to do all kinds of things. So I think it, you know, it will be the edge of our imagination. We'll be able to do all kinds of things that we've never thought of before because we now have totally new possibilities with the weightless environment.
This world of reduced gravity might have some interesting physical side effects.
It may be possible that if you're going to live there for a very long period of time, not only will the plants look different, but so will the people because you'll be in 1/6 gravity. The person may grow taller and thinner, so that you may have, with people who live on the moon for a very long period of time, truly physically different looking people than the people on the Earth. We ran some studies a long time ago on chickens in reverse. And what we did was we had a 1G chicken, and we had a 3G chicken, and a 5G chicken, and we let these chickens grow up. And the 5G chicken had a leg that was as big as my arm, okay, because the gravity was so strong. And the 1G chicken, of course, was a little better, and you got the plain old, you know, regular chicken. And so the opposite is going to happen when you go to the moon. With less gravity, there'll be less pressure on the bone structure as it grows. There'll be less pressure on the body as it grows. And so there's a real good chance that there will be totally physically different looking plants and animals and people and everything if they're born and grow and live in that gravitational environment for a very long period of time.
You mean we might create a whole society of little moon children and Martian children that would look distinctly different?
They may look distinctly different, yes. But they'll all be human.
A colony on the moon. A colony on Mars. Others foresee a third possibility. Free-floating colony capsules, not attached to any planet. One such colony plan was created by Gerard O'Neill, a Princeton physicist who designed what many feel may become the space city of the future, as seen in this simulation.
The original space colony concept was very low technology, and we want to keep it that way. Basically was to be able to reproduce in a reasonable sized environment of at most 1 or 2 square miles. Something which is very Earth-like in terms of grass and trees and flowers and water and so on. And that still makes sense because it's within the historical tradition of we humans, unlike, say, snails and various mollusks and so on that adapt themselves to ecological niches. Our whole history has been that we keep our physiology the same and we build habitats which suit that physiology. As we go out into space, we're simply doing more of the same.
And Jerry makes the point that if you're going to go and create a colony to live in space, you don't have to go down onto the surface of a large planet like Mars and then use the gravity to hold the atmosphere there. Why don't you just turn it inside out and build a large space colony out of materials that you can get on the moon and the asteroids and put the atmosphere inside the colony and live on the inside of this shell? It would be essentially a gigantic spaceship, a mile or so in diameter perhaps, several miles long. It would spin very slowly, which would give you an artificial gravity, so the water and the people would hang on out in the edges. And by having large mirrors to bring the sun in, you could time it in such a way that you have 24-hour days, and you could have the seasons of the year, and you could have a very fine controlled environment.
Many feel that only when space colonies become truly comfortable will they have a real future. Others feel that no matter how appealing, the whole idea of colonizing space will never be economically justifiable.
And until life can flourish all over the planets and in the solar system, it's not so exciting for us. It's only when you can plant things and grow things and live there more or less in a more or less free environment and more or less open environment, not in the malodorous capsule, or so, that it becomes really worthwhile to colonize these places. So I think space colonies shouldn't be considered as something just for human beings. Space colonies are for life as a whole. And then it begins to make sense and to become attractive.
I think the idea of colonizing space, that is putting large numbers of persons out there to make a settlement that expects to grow and become more or less independent, I can't, of course, foresee the entire future, but it seems to me extremely unlikely. Again, I come back to Antarctica. I think that, yes, those places will be occupied for temporary or even enduring explorational scientific ventures, just as Antarctica is. But it's so hard to make a living there. The capital cost is so high that until the Earth has become so crowded, there's no more space on the oceans. I don't think we're going to occupy those places in any great detail. Unless some great economic advantage accrues from it. You find some substance worthy of carrying back. Or maybe the power stations in orbit have some marginal viability if they work out well. I don't know. But, you know, we do have a lot of sea space in this world. And at this moment, as we're talking, there might be one person in 2,000 or 3,000 of the whole world population on the sea. Capital cost of being out there safe for a long time is very high, and so until you're really pushed, you don't do it. Now, eventually we're really pushed, and so we'll probably have this and that going on there at sea. But until one has seen that happen a lot, it's too soon to talk about doing it into a much more remote environment like Mars, where there's no air, 1%, and there's not much to be done. You've just got to make a whole environment for yourself. I think it's very difficult to do.
Many, however, do believe that this is where the future will take us, and some speculate that it could be a wonderful new frontier, while others fear it might be a looming social disaster.
I think that the very fact that we're going to have a very large amount of robotic support will mean that instead of having a master-slave relationship, it will be men and machines, with the men very much in the role of the free individuals, and the routine dog work being done by computers and robotic systems. What type of society evolves when instead of having the old labor capital type of confrontations, you've got machines and brilliant people who are deciding their own destinies and the machines supporting them? But literature will develop, trade will develop in ways that it's very hard for us to see. The main thing is to not let it become bureaucratized, not let it become a very harsh military type of pyramid structure. We've got to develop space in a way that makes it open, that makes it multicultural, that makes it possible for mankind really to develop his full individual potential.
I think that such a society is highly vulnerable against the deviant personality who may get so disgusted with the whole thing that he's going off someplace and pull the plug and let all the air out of the space station. Now, the difficulty is, if you don't want to have deviant personalities, you probably wouldn't get an Einstein or a Beethoven either. These people who march to a different drummer, who have the great ideas, who create things for us. Personality is such a fragile, such a complex kind of thing. I just would not like to be on a space colony where the thought control would be far worse than George Orwell's 1984, just to make sure that the space colony could arrive intact at some distant port.
It's a very fundamental thing. The Soviet Union, for example, has set as a specific goal the building of settlements in space colonies of some kind, which relate in considerable part to work that I've done over the last 10 or 15 years. They go along with it to a 90% level, but then the last 10% becomes ideological, and they feel that it's extremely dangerous to assume that people should be left on their own to run their own lives out in space in colonies, very much the way our ancestors did in the Western world. They would like what they call literally a cosmic collective, and you can imagine where they want it ruled from, namely Moscow. And as people get dispersed out through the solar system in the next few decades, it's going to become impossible for any sort of cosmic collective to rule their lives. And as far as I'm concerned, a darn good thing.
Well, it is, of course, a problem. On the other hand, it's also a tremendous opportunity. I mean, one of my main reasons for wanting to go out into space, I mean, speaking now as sort of as an individual, is just in order to preserve some kind of diversity of cultures. That one of the great problems is our planet is too small. We're getting too homogenized. And it's very, very hard for minorities, cultural minorities, to survive. We're just too close together. Whereas there's lots of room out there. And so I think it would alleviate a lot of our cultural problems and social problems if people who wanted to live differently were able to go out and be different in different places. It's a long time since there was anywhere on Earth where we could actually go and be alone. It's not clear that we're going to stay in charge, you know, and once the thing gets loose. And so it is not just a matter of the human beings. Human beings have been here only a short time. Life has been here a great deal longer. So I think we should be humble about our role in the business. Maybe we're just the midwives. And it's very hard to set limits then to what can be done. As always, of course, when life once gets started, it sets its own rules. And it will start then to evolve and to propagate without our help.
The Great Space Race is made possible by a grant from the Boeing Company in tribute to those who have dedicated themselves to the exploration of man's next frontier. Companion reading for The Next Civilization is available in bookstores. It's entitled Pioneering the Space Frontier.